We've got David, pronouns he, him, calling in from Tennessee, says that scientists don't approach space-time consistently. David, what exactly do you mean by that? And also, how are you?
Hello.
Hello.
Can you hear me?
Hey, David.
Yes. Yeah, I wasn't sure if I was going to get through. So, okay, so what was my question?
Yeah.
If you could repeat it.
What I said, it says here on the call screen, scientists don't approach space-time consistently, and I don't know what that means.
Oh, okay. So I was just going to throw something out there. I'll just let you know ahead of time that I am a creationist, but I also have an interest in science. And I've, there was a time when I struggled with my faith because of the science, but then I flipped the other way. I flipped towards the Bible perspective. But anyway, the question is this, and I'd maybe address another issue too afterwards. Einstein made space-time famous. I don't know if anybody considered it beforehand, but it was proven shortly thereafter by solar eclipse that starlight bent as it passed the gravitational field of the sun. And so we know that light can bend as it travels through space. Yet scientists, when they try to measure the distance of stars and therefore approximate time based on the speed of light, is it not the false assumption that the light is traveling perfectly in a straight line in order to do a triangulation, to the billionth degree or whatever, which is also pushing it? Is there an inconsistency? Do they assume a perfectly straight line if they know that light bends as it travels through space?
Right.
But the whole triangulation is dependent on the light traveling in a perfectly straight line. Which
So the difference here is that light does. So what you're talking about, gravitational lensing, light being bent by a massive object as it passes around there. That's going to have varying degrees of severity based. Again, I'm not a physicist. This is just something that I happen to know because I've studied it enough. But you've got varying degrees of severity to this. So if we're talking about bending around a black hole, then you're going to have some serious bending there to that light, and you're going to be way off. But if you're talking about bending around a star or a planet or something like that, not so much. It is going to happen, but not quite the same way. And if something's behind a star to be bent that way, you're just not going to see it, probably, more likely is the case. So when we talked about the gravitational lensing that we saw in time of Einstein, we saw that during a solar eclipse, that the things behind the sun did actually, we had this little bit of warping, this little bit of lensing there. But when we're talking about things that are way far out in space, not that big of an issue. And also, if there were something in between us and that thing, we would probably know about it, and we would take that into account. And also, when we talk about things like that, what we're more interested in is motion. And so things like red shifting and blue shifting, I don't think are affected by lensing in that way. So that wouldn't matter anyway. It's not as big of an assumption as I think you're making it, and I don't think that it matters that much.
And David, if I may, I have the opposite story of you. I was a young Earth creationist up until recently, and flipped and was studying science. So you gave me a trigger word there of something that I used to hold to as well, and that is the triangulation, and that of course is a common young Earth creationist argument, is that there is not enough distance between even the furthest points on the Earth to properly, triangulate as you would in trigonometry or geometry, the three different points, and decide the angle so you can tell the distance. As Forrest just alluded to, scientists do not in any way triangulate to find the distance from stars. What they use is redshift, blue shift, these shifts. And I had to learn this recently myself. So this is why I'm saying the triangulation argument is garbage. That's not in any way how it's used. So it doesn't matter if light is bending or not. What you need to look at is look up redshift, look up Doppler effect, look up those things which are unaffected, or at least not altered by gravitational pulls of black holes or anything like that. Those wavelengths.
I have another question.
But those wavelengths don't change. So, okay, go for it.
Yeah, there seems to be a problem with redshift likewise. But to backtrack a little, I do agree that the black holes, suns, anything out there. There's billions of things out there in between that it's bending light all over the place. We don't know. I don't know anybody that knows how many direction light is bent, and sometimes we're depending on a perfectly straight line. And I do treasure hunting from long distances. I know how, like it's a 50-to-1 ratio per degree. Every 50 feet is 1 foot. So it gets way out of kilter.
Do you acknowledge
but
do you acknowledge what I just said, though, that triangulation isn't how it's used, and that redshift has to do with wavelength? But redshift has to do with wavelength, but redshift is the wavelength is not altered when things are bending, right?
Yeah, so I have a
that's
question
the
about
direction
the
of the light.
Yeah, there's a problem with the redshift too. Also, let's say that redshift implies that there's different kinds of redshift. Okay, the one that's mainly used is where an object is traveling away, and it shifts the light to the red spectrum or whatever. So it's an indication it's traveling away. It's actually accelerating. They say it's accelerating outwards, right? But if the universe expanded or exploded or expanded or is going outwards, which is what this seems, there's several problems. One, if we're seeing it expanding in all directions from the Earth, that means that the Earth is exactly the center of the universe. And what's the probability of that? But the question is this: if it's expanding outwards, if the universe did explode, and it's an instantaneous explosion, for example, and now it's accelerating. But the problem is acceleration is slower than instantaneous. So it actually it should be decelerating after an instantaneous acceleration. You see what I'm saying? So there's a problem with it being red-shifted.
Yeah, no, that's neither one of the things you just said are accurate.
Take them away.
It should not be red-shifting if we had an instantaneous acceleration in the past. I mean, it was boom, it was there all of a sudden, faster than light, instantaneously. Nothing is faster than instantaneous, so therefore it would have to be slower than instantaneous or decelerating is what it should be, but it's not.
David, I just want to be clear. Literally every part of what you just said has a problem with it, and I'm going to try to work through it systematically, but I'm going to miss some steps. So forgive me. I'm going to do the best I can here. Number one, you said that the Earth has to be in the exact center of the universe, and what are the chances of that? Not really. The idea is that the universe is finite, but without true boundary. So that would mean that literally everywhere is the center of the universe. That's more of a talk for later. It's not important. What is important, it'll help clarify this for you, is that what we're talking about is all of space expanding. Space itself is expanding. So everywhere you go, all of space is expanding in all directions. So that doesn't mean that Earth is the center of the universe. No matter where we were ever, all of space would be expanding in all directions. It would look that same way. So we're not saying that this is the center of the whole universe and we're so star-spangled special because of it. That's not how that works. The second thing is that you're talking about redshift is distorting this light because it's accelerating or whatever like that, because space is expanding. So you have these two galaxies and there's light coming off this galaxy. The expansion of space driving the galaxy in that direction is what's causing that redshifting. So it has nothing to do with rate of expansion as opposed to an instantaneous whatever. It's just as long as there is acceleration, as long as there is expansion in this other direction, you're going to have that redshift in the exact same way that if a car is driving away from me and blaring its horn, there is going to be a distortion in the sound because the car is driving away from me. It's the exact same thing. It doesn't matter how fast they were moving now or then or whatever. The motion is what's causing the distortion. And it's the exact same thing we talk about different galaxies. It's also really important to point out the fact that when we talk about the Big Bang, we're not literally talking about an explosion. We are just talking about the beginning of the expansion of space. And that expansion is carrying on to this day. In fact, it's kind of more rapid because space itself is the thing that's expanding. The more space there is, the more rapid the expansion will be. And this is why we see Hubble's constant. The farther away a galaxy is from us, the faster it's moving away from us. And the way that this is commonly explained is if you think about a lump of raisin bread, right? As the bread expands, the raisins move apart from each other. If two raisins start out close together, there's only a little bit of bread between them, so they're only going to expand that little bit. But if two raisins start out far apart, the expansion rate of the bread is the exact same, but there's more bread expanding, and so they move apart faster, and because they were already far apart to begin with. And we see that exact same thing in the universe now. More distant galaxies are going to be more redshifted. They've got more space between us and them. The space is what's expanding, and therefore we see greater acceleration. It has nothing to do with the instantaneous acceleration. The acceleration rate of space, as far as I understand it, has been consistent, but now there's more space to do that expanding, and therefore the acceleration is faster than it was at the beginning. Does that make sense? You understand what I'm talking about here?
Yeah. Well, I kind of do, but it also brings up another interesting question, which ties in.
David, before you gish gallop, another question. About, David.
Yeah, about the beginning, time, space.
Well, hold on, because Paul had a question for you really quick.
David, before you throw yet another thing at us, because this feels a little bit like normal creation gish gallop. It's like we answered the three things you wanted, and we gave great answers to those, and you have a script to read the next one. And I'm hearing the same talking points that that's fine. That's from memory. Doesn't you're using the same talking points that I used to use, and but I now understand that the way to. With the, but hold on. What you need to do, David, what you need to do is look at these things not from material from a creationist, and this isn't to change your mind, but you're using the verbiage of creationists and asking the questions. What you now owe yourself to do, if you care about truth, you owe it to yourself to read what the scientists say and use the language that they use and try to figure out which one you believe, because you're coming at us with the limited creation lingo, which is not what the scientists use. And it sounds to me like these are things that you could easily look up, and you're just throwing one after another at us. And it sounds like either you've heard these answers before and don't care what the answer is, which is not a great way to have a conversation, or that I'm worried that, like me, you've been taking this all at face value and accepting the view of the science from the side that you're on. And what I would just beg you and love you to do as we wrap up the call, and we can do one more question or however Forrest wants to manage it, but please go look at this from the other side, even if you want to reject it, but at least understand what the flip side of your argument is before coming at a biologist and a computer scientist and asking these questions. So that's just my plea to you, David. Too. Great.
Yeah, I'm a computer scientist, but I have one more question, which I think would be interesting, and I haven't read this anywhere, so this is brand new stuff. Space-time. We keep talking about the beginning, before the beginning, and it's a big unknown, But if there is a beginning, then time has a beginning and an end. And if time has a beginning and end, then space-time has a beginning and end, which means space has an edge. And as you approach the edge of space, you approach the edge of time, which would give you an illusion of whatever we may detect.
What?
I mean, just think about it, because I've never read it. I don't know about you, but I've never read that concept anywhere. It's something to be considered.
How is the edge of space the same thing as the edge of time?
They're interlinked. You can't separate one from the other. So if there is a beginning of time, there's an end of time, and if there's a beginning of an end of time, then there's a beginning and end of space-time.
We don't actually know that.
That concept has never been approached.
Right. So the whole thing, yeah, you're right. Like space and time are kind of like electricity and magnetism. They're two sides of the same coin, and they're connected together, and that's why we have. Also was electrician. That's why we have time and space dilation when we talk about, like, if something's moving faster, then time and space contract, or time dilates and space contracts. I think it is. And so like you have this issue of like, however you're moving and how fast you're moving and from what perspective you're seeing the motion, distance and time become relative. This is the whole concept of relativity. But like that doesn't then follow to the idea that like at the end of time, which I don't know what that would possibly be. There's also this edge of space. Like, I don't think that actually makes sense in as far as I understand it. Again, not a physicist, but like, as far as I understand it, that's not how that works.
If also, time ends, then the universe laws change at that point.
But we don't have any reason to believe that.
Yeah, everything depends on time.
But David, we don't have that if. Like, we don't have that if.
David, would you agree that
nobody was there at the beginning to tell us what the beginning was? I mean, none of us, either side of the argument.
We just have a tremendous amount of evidence for the
either way you go.
David, would you agree that the set of positive numbers is infinite?
If you make it infinite, if you subdivide infinitely, it's infinitely
microscopically
and macroscopically.
But does the set of positive numbers have a beginning?
Well, I don't know. It's mathematics. I happen to have a minor in math, but
it's not a trick. It's not a trick question.
Start counting.
Well, okay. Look, you're a computer science. Let me go to vectors. Okay, is a vector infinite?
Well, you've got a point of angle and magnitude, right?
Yeah. So a vector is infinite, and it has a starting point,
because it just keeps going that way.
But it has a starting point. Of all the vectors described, has a starting point and an angle. So again, it's not incoherent to talk about. It's not incoherent to talk about infinite things that have starting points. That's just. I mean, I don't think your point made any sense in general, but it's not incoherent to talk about.
From a biblical standpoint, you can say, from a biblical standpoint, a human soul has a beginning, but it has no end. Just like a vector.
Right.
Cool.
Sure.
So apply that same thing to time. Time has a beginning, but it has no end.
Well, no. Time is space-time. So if you remove time, then you have infinity. Only if you remove time.
But what? No, but
actually,
you just said the same thing twice.
The absence of time. What I meant to say is the absence of time is eternity. If you remove time, if you could remove time, which we can't as humans, it's humanly impossible to conceive such a notion. So
what you just did was exactly what Paul just said. That positive integers, I think that was a great example. Mm-hmm. Positive integers have a starting point. It could be 0.0000. You could make an asymptote. It could be an infinitely small number, but it is a number and it is the starting point, and then it goes on forever. And you can't, that doesn't change anything about the fact that the numbers now are real. So time, that's what we're looking at with the Big Bang. We have an asymptote. We can go infinitely far back to the closer and closer and closer to the beginning of time. But there was a beginning, and now we just go forward with it. And we have no reason to say that there's an ending point to it. Just because it's intrinsically linked with space doesn't mean anything. Space is ever expanding. Time is ever expanding.
Yes, but it's an analogy, and analogies aren't the exact same thing. They're similar.
I'm not saying that it's exactly the same as numbers, and he's not saying it's the exact same thing as vectors. We're just saying that it is possible to have something that has a beginning and is also infinite. Time and space are those things too.
It's possible, but that doesn't mean that it is the case.
Right, and you and I will not be around to know.
Yeah, so just as far as the evidence points us right now, as far as the evidence directs us, that's the way that we have it set. So until we find evidence contradicting that, then we can change our minds and say, aha, no, there must be an end. But until we get to that point, this is another thing is, we talked a little bit ago about that Universe from Nothing book. One thing that I do remember from it that I've talked about quite a bit is that we live in a flat universe. If we lived in an open universe, the universe would expand forever, increasingly like crazy, and there'd be a while. If we lived in a closed universe, it would have a great crunch where everything collapses back in on itself. But being the flat universe that we seem to be in, we have this consistent, regular expansion pattern, and we have no need for finite limits on the ends. So, again, like we said to the first caller, way smarter physicists than I'll ever be are grappling with the same thing and don't seem to have the problem that you're having. And even me with my undergraduate education, I can tell you what you're saying doesn't make any sense in this way.
Well, did you mention earlier about tinnitus, like the ringing in the ears? Did I understand that correctly?
A caller did. We didn't.
Yeah.
Yeah. Oh, well, tinnitus, I've done research on that, and it's a simple matter of asking the person what is the range of what you're hearing. Is it higher? Is the note higher? Is the note lower? And I was able to narrow it down to a specific frequency, and it just so happened to be the same resonance frequency as what Dr. Clark said was the cause, which is one of the causes was Streptococcus pneumoniae. She had that right before she got the tinnitus when she was a teenager. So we're a step closer to establishing a potential solution is by eradicating it with frequencies.
Who?
The pathogen.
I don't know what.
Should go away.
I don't know who Dr. Clark is, and I know we do have an actual, we do have student Dr. Ben is actually in the back room right now, saying that he wants to have a debate about tinnitus. He seems pretty amped up. So, this doctor that we have working with us right now seems to not be impressed by that. I don't know who Dr. Clark is. Okay. I have yet to be convinced that bacteria can be cured by frequencies.
David, I hope you're right. I hope you're right that we're close to cures. That'd be great.
There's no known cure, so nobody knows what they're talking about until somebody cures it.
I don't know if I agree with that, but we're going to move on to the next thing. Check out student Dr. Ben's channel and check out his show called Medical, I believe it was Medical Mysteries, wasn't it? There he talks about all of these things. I'll clarify. Medical myths, that's what it is. Medical myths over on student Dr. Ben's channel. Might be able to elucidate some of this. With that, David, we're going to go and move on to the next call. Thank you so much for calling in.